Hi, Math 8 students. So today we're jumping into a whole new topic. And so this will be topic 6. We'll probably go at about 2 lessons per week. And today we're going to tackle 6.1 and 6.2. So what we're going to try to do is we're going to try to be able to describe things like transformations, translations, and reflections. So a little bit of vocab heavy at the beginning. So what I would recommend doing for this is basically having a little journal of the term. So maybe like a journal, a little description, a little notes on the videos that we're posting. Then you can kind of reflect back as the topic goes along. But today we're going to look at these three concepts: transformations, translations, and reflections. And we're going to start with transformations. So transformations, I've posted these little transformer toys, which you might have seen the more recent movies. Basically, you can think of each of these just kind of transforming into something else. So it's the same exact stuff, but it has taken either a new form, a new position, a new shape. So transformation, that's kind of like our base of this entire unit, is just different types of transformation. So basically just a change in position, shape, or size of a figure. And we'll look at kind of like two subtypes of transformation. So two types of transformation we're going to look at are translations and reflections. So we're going to start with that exploration problem I posted for Tuesday morning. So I would recommend not spending more than a couple minutes on this thing. I just want you to think about it. So if you haven't done this already, just pause, think about it for a couple minutes, and then come back and resume the video. So anyways, we got a student drawing a trapezoid on a coordinate plane. So we'll call this figure 1. And so I'm just going to go ahead and label the coordinates of it so you can say this figure kind of has 4 points to this. We'll call this A, B, C, and D. And so basically she then draws figure 2 over here. So we're asking how can she determine whether the figures have the same lengths and same angle measurements, which is basically like asking, is it the same shape? And so we'll call shape 2. It has vertices, and so to label it, they're the same but kind of different. We'll label it like A prime. That's what I mean by that little dash up there, little geometry notation. We'll call it B prime, C prime, and D prime. And so what you can say is that basically if I were just to measure all the properties, like the lengths and the angles, I could say, well, I'm going to come over here and I'm going to measure angle A. And if I measure this angle A, I should get the same as just this figure that's moved over. So I could say that measure of A is the same thing as measure of A prime. And I could do that with angle B, I could do that with angle C, I could do that with angle D. And basically, we can just come over here and measure all of them. So what you did in this exploration is actually called a translation. And if you look at kind of these points over here, looks like about 17 probably. You could say this was just translated 17 units to the right. So A was translated, B was translated, C was translated, D was translated, and what you got was basically a figure that was just translated to the right. And so we've got our first definition, just a translation. So a translation is basically just a type of transformation that moves every point of the figure. So you can see that A went to A prime, B went to B prime, C went to C prime, D went to D prime, the same distance. So it all moved 17 and they all went the same direction. They all went to the right because you could see if I move B like 17 units in this direction, suddenly I'd have some strange figure like this, and that would not be the same figure. So same direction and same distance. So key things to a translation. So we've got two definitions down already. We're moving kind of quick. We got transformations and we got translations. And one thing that you might see is, I always like to relate this to something you might see before, is you see this in games all the time. So pushing blocks, like a very classic game trope. So we could say every time Link presses a block, he's just translating a figure. We got point A, B, C, D, or it could just be a single point. He's just translating it around a coordinate system. So let's move on to a more mathematical example of this. So I have got this figure here, and we're going to look at kind of how to mathematically implement a transformation. So our task here is we're going to translate this polygon, and they describe it just with kind of the points on the outside, which are called the vertices. We say vertice A, B, C, and D. We're just going to translate it, and they're giving a specific amount of units and a specific direction. So 8 units down and 3 units left. So we're just going to implement that transformation. First, though, there's going to be some things that happen with the coordinates that we're going to want to look at. So I'm just going to record here every single coordinate. So A, B, C, and D are what we're looking at. We're just going to record all those coordinates. So we got A, we go 1 left, 6 up. So that'll be at -1, 6. B, if we look over, we got 4 to the right, 5 up. So that's at 4, 5. C, we come over here, it is 2 over, 2 up, so 2, 2. And D here, well, we don't have to go up and down at all, but we have to go left 2, so left 2, up 0, -2, 0. And so now what we want to do is we want to translate now. So each one of these tells us to go 8 units down and 3 units left. So what I'm going to do here is I'm just going to go through piece by piece, and I'm going to translate each one 8 units down, 3 units left. So we're going to we'll start with D right here. So let's go 8 units down. It starts at 0. It'll end up down here at -8. We'll just label that. Then we have to go 3 to the left. So 1, 2, 3. We end up right here. And we can't give it the same name. We went 3 left, 8 down. Let's call this D prime, our translated point D. So next we just go through, we do that for each point. So we'll do that with A. I start here at 6. So I'm going to go down here to 2. And then I go 3 to the left, 1, 2, 3. We got A prime. B, let's go 8 down. So if I go 8 down, I get here to -3, and then I gotta go 3 to the left. Gets me right here, B prime. And we've got one more point to do. I just gotta do C. So this one will end up right here if I translate it. So we got C prime. And now all I gotta do is connect the dots. So A prime to D prime looks like pretty much the translated image of this side length. We'll connect here, and connect. Just fix that point really quick. Connect here. And we've got this same image just translated downward. So the entire thing went 8 units down, 3 units to the left. And we've got our new image here. So let's go ahead and record those images, or record the coordinates and see what happened, because there's going to be specific things that happen to the X and Y that makes these quite a bit easier to just do without having to plot it like this each time and do like this counting over that I'm doing. So let's go -4, -2 is A prime. We've plotted that. B will catch the coordinate B prime. That became 1, -3. And we'll do that with each point C prime. Okay, so we got -1, -6. And D prime, if we count over, I'm 5 to the left, 8 down, so -5, -8. And so let's look at what happened to the X value, or to, the X values. So the X values, I can look over and say, well, each one of these, if I look at on the graph, A went over to the left 3, but I can also look at the coordinates, -3 to -4, that's like subtracting 3 from it, 4 to 1, subtracting 3, 2 to -1, subtracting 3, -2 to -5, subtracting 3. So the changes in the X values, I can just say that subtracts 3. So if I want to get the new X coordinate, we have this arrow diagram, and I can say, well, it's just the X coordinate of the original -3. Now I can do the same thing with the Y. So 5 to -3, that's a drop of 8. 6 to -2, that's another drop of 8. So similarly, I could check them all, but I don't need to. I could just say the y values subtract 8. And with my arrow notation, I could just say, well, the new y coordinate is just the previous y coordinate minus 8. And then we can describe it using this arrow notation. So you could see here, if I just did this, I could do this way quicker. You can say, oh, -1 minus 3, that'll give me my -4. 4 minus 3 gives me my 1. I could find these way quicker just with this like translation guide with the arrow notation. So let's look at one more type of transformation. We're going to jump forward to 6-2. So we've got kind of our translation where we're just kind of moving left and right. Let's look at reflections. And these are pretty intuitive. So really, we can just look at this in the real world with a ton of different examples. So we can take a look at this tree here that's been reflected. And then, but what I want to be very specific on is a reflection is defined as a flip of a figure across a line of reflection. And you can even find that just with a real world example. So if I were to look along here and say, where is this tree reflecting? I would just say, let me not use a black marker across. And I could just say, well, it's flipped right along that axis. So you've got your tree, kind of your pre-image, being reflected onto here. So like this point, which is this far from that line, is now the same distance, but just on the other side of it. This stump here, or this like top of the trunk, is reflected across, and everything is the same distance across this line. And so we can implement reflections as well. So let's take a look at a mathematical example of this. So I'm going to take the same figure as before, but instead of translating it, I am going to reflect the polygon, and of course we can't reflect it without a axis to do it of. I'm going to say over the x-axis. So we're going to implement a reflection of the same shape, and we're going to do it over the x-axis. So let's draw a line for our reflection. So I'm just going to do a dotted line. We've got our x-axis running across here, and I'm going to reflect across this line here. So same coordinates as before, so I just copied them over. So we've got our A, B, C, and D, and we just want to reflect them. So let's start with A. So A is 6 above, so we're just going to reflect it along that line just like a reflection does in real life, and we're going to reflect it 6 down. So what was 6 is now down here at -6, and we'll call that A prime. So now we'll just do that with every point. So here, this was 5 above. So let's pop it down at 5 below. And we got B prime. C prime was 2 above. Let's put it at 2 below. And D is kind of the interesting one, because if you can see it's right at the base here, it won't really reflect down at all. So D actually stays where it is. D is the same point as D prime. And now we just connect our dots. So I'll go ahead and connect them. Let's use a solid line for that. So we'll go ahead and connect our dots, make our polygon. And we've got our new reflected shape. So you can see it's just mirrored over here. And so now we're going to look at how do we use that sort of like arrow notation for reflection. So I'm going to go ahead and record the new coordinates. So we'll start with A prime. So A prime, let's see, the x stayed the same. It was still 1 to the left, so we'll write -1, comma, oops, and I made a mistake. That's not at 6, it's now reflected down, so -6 because it's 6 down. B prime will do the same. So it was still 4 to the right, but it was 5 down, so 4 comma -5. C, that was at 2, but now -2 for C prime. And finally, d prime, that is going to be at still -2 and still 0. So actually the exact same as just the original point D. That one didn't change. And so if we describe the changes in the x, you'll notice a was at -1, a prime was at -1 for the x coordinate, b was at 4, b prime was at 4, c was at 2, c prime was at 2, d was at -2, and d prime was at -2. There was no change, which you can think of x as like horizontal position. If I'm reflecting up and down, the horizontal position of any of these points on this tree did not change, so kind of expected. So we're just going to say if I want to get from my reflection to my new one, if I'm reflecting across the x-axis, the x is just going to stay the same. X becomes x. There's no change. However, everything on the y-axis, 6 became -6, 5 became -5, 2 became -2, 0 became 0, and you can imagine if I had a point below the axis, it would flip up. We can just say all the y values just changed sign or flipped polarity. So any y just became -y. And you can kind of imagine if I took something where it was like, well, what if I took a reflection that was vertical, like across the y-axis here? You'd see that, well, the y would stay the same, but the x's would change signs. So here we kind of have a rule of thumb for reflections across a specific axis. And you could see if I tried a different axis, I could make a new rule for it. So on that kind of covers the basics. So we'll do kind of like a practice session on Wednesday, so make sure you show up for those office hours. So I will see you guys later. Take care.